Steve, I'm so excited that we are here to share a vibe coding with Steve and Gene. This is episode 7. I'm Gene.
Welcome back. This is Steve.
Yes, the goal is to share with everyone what we've learned while writing the vibe coding book that comes out in early October. And I'm just so proud of how the book came out. It was such a fun book to write, which we'll be talking about today. It's such a fun book to read. Read it many times. I just love it, Steve. And the goal of the book is to show how every developer can be using vibe coding to help them do their work better, have more fun do it, and have more fun doing it. And so our goal is to record one of these every couple of days, jump into a section of the book or a section of the book that never made it in, and share with you in amazing detail, like how these principles and patterns apply not just to coding, but maybe even writing. So, Steve, we are this is part of the second episode on the techniques we use to write the book and what it illuminates for vibe coding.
We are going to show you how we wrote the book. We're going to do a section of the book that we've never done before. It's going to be a somewhat abbreviated one because usually, how long would you say we spent per section, Gene?
You know,
Minimum, maybe more closer to an hour.
we'd be lucky if we could get 3 sections done a day. That'd be a great
Yeah,
day.
so it was
Few
a
sections.
solid hour and a half of really hard work per section, sometimes
Yeah,
longer. So we're
yeah,
going to do this, try to bust through this one in like 15 minutes. So we'll do a short section, but you'll get all of the basics of how we wrote the book.
yeah. So I'm pulling up REPL session here. So the topic, so we actually had a section that is near and dear to our hearts, which is, in fact, oh my gosh, I got to spend a couple of days with Kent Beck in Tokyo, and we spent a lot of time talking about REPLs and small talk and Lisps, and what they all have in common is they have a live running environment all the time. And what's magical is that if you have a live running program, you can inspect every object. You never have to shut down the program. So the compile, the right compile run cycle goes away. You're always inside your running program. And Kent Beck wrote his first book in Smalltalk. I think it was in 1996. And to this date, he is still trying to write a Smalltalk environment for the modern age. And Steve, you too have a long-standing love of REPLs. Can you tell us about that?
Yeah, gosh, this goes way back. And it's funny, I'm glad we're doing this because I don't think a lot of engineers necessarily, I don't think they all necessarily have this in their toolkit, their vocabulary. A lot of engineers, especially like if they're programming in like C plus, Go, Java, stuff
Python.
compiled like not Python. Python people get it, I
Oh,
think.
right. And in notebooks, you have a kind of REPL-like environment for sure.
Yeah, but the compiled languages, I think they don't really fully appreciate how powerful REPLs are. Because a REPL just seems like, oh, I can test out some expressions interactively, which is actually really helpful,
Right.
especially if you're writing Lisp, because then you can make sure the parentheses are balanced. But it goes so much deeper than that because, like Gene said, it's a live environment. It's your program. Like if I'm logged into a REPL, which is a read-eval-print loop, REPL in all capital letters, all right? A read-eval-print loop, which means it reads what I type and evaluates it, and then it prints a result in a loop. Okay, that's all it is. But it's running through the interpreter, right, of the language, whether it's Python or Lisp or Smalltalk or JavaScript, right? Any dynamic language can have a REPL. Even Java has a REPL, like with Bean Shell, right? Not a super great one, but it works. But the thing is, you can call functions in your live program from the REPL. You could log a player in. You could change
Right.
the color of their shirt like dynamically. And when I realized, wow, I mean, this is like when I first started playing with these, why would you not want to embed these in one of your programs? Because like it's like a debugger too. You can be like, yo, what's going on in the program over there? And like check in the REPL and it'll tell you exactly what's going on, right? It's a huge security flaw. You don't want to like leave it running on an open port, launch it to production, but it's an amazingly powerful tool. And then what we found, I mean, look, you got me started on REPLs. I could talk for the next 35 minutes about REPLs. I'm going to pause there. I'm going to say we did find some really interesting stuff that would relate to AI and REPLs.
Yeah. And let's just go a little bit longer, right? And so what is the value of putting a REPL into your live production server, right? You actually put in Python, right? Python for the JVM so that you can
Right.
do all these amazing things to your live running production server without taking it down.
So just to give you an example, like my game has a REPL in it, right? Per wizard. A wizard is an administrator, basically. And so they can log in and they get a REPL, which means like like let's say a player gets stuck. Like once a player gave a really expensive artifact to a monkey and the monkey ran off. No, the monkey stole it actually. And we didn't know how to get it back from the monkey because I have a REPL in the game where I could like command the monkey to do stuff, but it was ignoring me. And so like I literally had to go into the Python REPL, find the reference to the monkey in the game's, monster data structures, like go down and look at the monkey's inventory and find the player's artifact there and then say, okay, variable I is the player's, whatever, P player. I'm going to move this artifact over here. And then the game updated automatically because I had performed the operation programmatically from behind the scenes, right? Super cheating. You would never do this like when you're actually building a program, right? Because it's monkey patch. Literally, we're monkey patching a monkey. I hadn't actually thought of it that way, but that's what we were doing, right? So REPLs are wonderful because they're like, I don't know how to, they're like a robot that you put inside of the code that
Yeah,
could help
right.
you.
Right.
And so yeah, I think every application should have a REPL. And
Yeah,
Emacs is effectively a giant REPL on steroids.
there you go. And Clojure as a REPL. And the reason why I kind of balked at the when you said Python, so Python notebooks have this property where you kind of evaluate the forms and then you can sort of go back and sort of change these live variables and so forth. But Ruby, Java, you can't really do that for a running program. The famous example is there was I think it was the first NASA craft with the ion drive, right? They had a piece that had a REPL in it, and they could actually upgrade the software and change it through the REPL. I mean, pretty awesome. I had an experience. So the reason why I think this is so topical is there's a guy named Bruce Holman. He's famous in the Clojure community. He's actually has some notoriety in the JavaScript community because he wrote a program called Figwheel that essentially set a new bar for like what code hot reloading would look like, to the point where it actually influenced Dan Abrams, who was famous for his React hot loader. That was actually inspired by the demo that Bruce Holman gave. And so he wrote a program called Clojure MCP that basically created an MCP around a Clojure REPL. And so he and I and Luke Burton from Apple, now NVIDIA, we got on a 2-hour call and he taught me how to use this. And it was amazing. And I'm going to share my screen. And here's what, share my screen. So it was able to find a race condition in a piece of code that I wrote. The code that I wrote in the last 72 hours of our editing process to help me copy and paste easier across 4 different Google Docs, that was actually based on some code I had written in 2022. That was a markdown parser. And that was before I learned how to use closures inside of, so I had this global variable. And I was amazed at how having a REPL could help it. I mean, it actually spun up 1,000 threads, to sort of replicate the race. When I asked it to create the contrapositive condition to prove that it could replicate the error and fix it, it was amazing. And so I asked Claude, can you tell me how advantageous it is to use REPL versus writing a program and running it? And I use it again for migrating from Google Photos API that they essentially deprecated to OS X photos, OS 10 photos. And here's what it said. It said, it's going about all the advantages, but it said to go from a feedback loop of 10 to 30 seconds per iteration versus 2 to 5 minutes, which might be a little bit overstated, saying it's faster. There was a compounding effect that, each discovery built upon the previous one. The psychological factor that says I can stay in exploration mode versus just engineering mode. And so here is Claude convincing me, making a very convincing case of how it likes REPLs more than kind of your classic, write, compile, run. And I was saying, what would it take for Python to have a similar REPL experience? And tell me what it would look like for JavaScript. Anyway, this is like a phenomenal essay of Claude telling me how much it loves REPLs. Steve, can you react to that?
Yeah, so I mean, I think Claude's made it pretty clear that it likes REPLs. It's just a matter of access. Like this is analogous to MCP. All right, MCP, the Model Context Protocol, is a protocol that Anthropic came up with that allows the AI to manipulate a tool through sort of a predefined set of calls that you're allowed to make. You define what the calls are. You know, it's a very kind of a rigid interface. I don't know that there's any dynamic discovery in MCP yet. I could be wrong.
No, no, is it, well, I mean,
I
you
think it's
can,
static. Well, if your system supports dynamic discovery and you have a call called make dynamic discovery, then that
yeah.
would work, right? But I mean, just like generally speaking, MCP is provides a fairly limited tunnel or narrow window to your tool.
Yeah,
Whereas the REPL is embedded inside of your tool and has
that's
literal
right.
access to every single data structure, every single variable, every bit of state in that program, in that running program. So, I mean, they're kind of dangerous, but when it comes to experimentation, like Claude was saying, right, or for trying things out, you know, they're absolutely indispensable.
Here's another example, Steve. I mentioned this Google API deprecation, and over a weekend, I was able to swap out Google Photos API. This is for my screenshotting analysis app to OSX Photos, which is incredible. But the fact is, like OSX Photos, like I didn't know what the data structure looked like. It's all living inside of a SQLite database, like that the Photos app uses. And so it was amazing watching Claude Code through MCP basically discover what the data structure looked like and figure out kind of the methods to use to download it from iCloud, and just it taking these live objects and understanding the shape of it, how it ties into the SQLite database, trying AppleScript calls to download it. And Steve, all through kind of MCP. That was just this incredible dynamic discovery process that a REPL enabled. And I've been recording since the beginning. I mentioned this because I want to give the Chow tool that context. All right, so Steve, why don't you back over to you?
Got it. So, when you said the REPL was through MCP, what did that mean?
Oh, the so I had my Clojure program REPL running open, and the Clojure MCP program was opened up by Claude Desktop, and it allows the following actions. It can load a file, it can save a file, it can execute commands, but more importantly, it can send commands to the REPL. Tell me what this data structure, what this variable looks like. Print out this variable.
So there's a tunnel. There's an MCP tunnel in.
Tunnel, yeah. Create this function, run the function, and actually see the output, and do that without having to save it, compile it, run it. It's all happening in this live runtime environment.
Yeah, yeah. Now, what'll be really cool is when the agent actually lives in the environment in process, in Clojure. The agent lives
Yeah.
in Clojure. Then there's
Yeah.
not even that what you don't even need the REPL anymore. It
Yeah.
is the REPL. I built that in Emacs. It's called a
Yeah.
Fleet. Okay. It's like a living REPL.
Right.
Yeah, it's pretty cool. I think Clojure will have that pretty soon eventually too. I mean, they're pretty easy to write.
Awesome.
They're
So we've
pretty
been
easy to
gushing about
vibe
REPLs,
code.
but we've been doing it for in service of a very certain thing with a very specific objective. Steve, I think what we're trying to do is write a section on why every coding agent needs a REPL and an MCP around it. And I think the main idea is we have to first explain what a REPL is, because unfortunately, certain generation programs have never experienced the joy of having a REPL and a live environment that it runs in. I think the second point is why, what is REPL? Why are they so beneficial? A concrete example of how a REPL, giving a REPL to a coding agent creates benefits. What do you think?
Let's see. Yeah. Would we have any? We could do gotchas. We could do. What are some other things you need to know about REPLs? Are all REPLs created
Huh,
equal? Let's see. Threading, states. There's a whole bunch of stuff. I mean, there's a lot of technical stuff in REPLs, but I guess the AI can probably take care of most of that. Um,
yeah.
I think that's good. I mean, we should probably ask the LLM if we forgot anything.
Oh, well, good, good. All right, let's see here. Let me share my screen. And Steve, I just realized, while you were telling your explain what a REPL is, that I should be recording it. So I turned on this transcription window here, and that's a program called Super Whisper, and is a transcriber, and so it uses this is a really nice transcriber, and then it sends it to an LLM to clean up the text, which is actually really not necessary but helpful. So I created a little section here called "Why Every Coding Deserves a REPL," and I'm just going to make a little outline here. What is a REPL? What are benefits? And example of coding agent benefiting from REPL. And then I'm gonna, when this transcription finishes. And so how long was that conversation? According to my clock, that was about 15 minutes.
That's about right.
And it's gonna wait for that. And so in our chow workflow, and I sure hope this works. All right, so here's our transcription. Enclosed. Below is a transcript of us discussing the following. Right, 6 paragraphs. I haven't done this in so long, Steve. 6 paragraphs, starting with 1 paragraph kitchen metaphor, and the rest explaining what, why, how, and value. And then
So now we've created a prompt.
Yep.
And we created the prompt by just putting a little thin wrapper around a conversation that we had.
Yes. And by the way, there are a lot of other prompts that this chow tool is going to
Exactly. You have a bunch of other prompts to get injected in, right?
yes.
Tell it what, how to do what it does.
Yep. Yeah. Like so there's a certain amount of context saying, here's our book, here's parts 1, 2, and 3, and 4. Here's our favorite lines to replicate style. And then so now we're going to put in our prompt. Oh, here's a little swing spinner.
So this is the part of the podcast that we probably need to like edit or run at fast speed or something because there are gaps of waiting periods in our process where we just have to wait for the LLMs to go do their thing.
Yeah, now this is about 2 minutes. I think kind of a full cycle. And then yeah, and so think about the compression to go from 15-minute conversation into 6 paragraphs. And so this is the draft generation process.
It's always interesting to see like how the different LLMs interpret what we've asked them for, right? Sometimes they get what we meant and what we wanted and they just run with it. And sometimes they'll fixate overly much on one aspect of it and we'll have to throw the whole thing out.
Right. And so by the way, there's 50 models running and
50.
Yeah. And then I think we're going to enter the second stage.
We would throw all the model output into a Google Doc and it would routinely, after like 2 conversations, get up to 600-700 pages and start training the system.
Yeah. Yeah. Which just shows for, to generate a page and a half, we literally read
100 pages.
Yeah, probably easily 50 pages. So this is a ranking function. So
sometimes we would just be like, well, this didn't work. We got to redo it. Do the whole thing again.
Yeah.
We wouldn't have to do the conversation again, but sometimes like the prompt just wouldn't be quite right or whatever.
And something we never actually, I do want to do the experiments. It's funny, Claude, I actually disclosed to ranking step which model it came from. So we kind of list the winners here. And Claude would often choose Claude. And we always wondered if we anonymized it, would it change? Okay, so this is all about REPLs and MCP. And so we would just paste it. Shit. Hang on. Save everything to a file.
This is the part that makes me think that agents are going to come for writing as well, right?
I think so.
Because there's just so much here that you've already automated, and yet, as you can see, there's still a lot left to automate.
Yeah. Final clipboard. All right, good. We're kind of in a weird broken state. All right, let's see here. 03 is the.
Okay, so what are we looking at? What we're looking at here is what Gene and I spent countless hours staring at over the last 6 months, which is model output with a score that I think Claude gave it, right? Which model it was, and then here's its 6 paragraphs, right?
Yeah.
And so we'd scan it. We'd be like, okay, is this getting the point across?
Yeah. Yeah, I just gotta, let me just slow down for a second and just read this.
Remember, you got to read 50 of them.
Yeah, the tasting spoon is the REPL. Imagine like every time you had to taste, you had to recompile it or something. It's interesting. But yeah, it's explain what a REPL is. And it's sort of saying any time you can sort of shrink the feedback loop is good. Yeah, I like that, right? It's NK over T. We're shrinking T. I like that. So I kind of like that. I'll bold it. Not sure if I understood the. Oh, look at that, and it's bringing up my Clojure.
You look, this one came up with a better this model O3 came up with a better metaphor for the kitchen.
Ooh, yeah. So I realized that to the podcast listeners, watchers out there, you're watching us read text, which is maybe but okay, you think this is better. That's great. So O3, interestingly enough, and O4 are the top ones. I'm just gonna scan down here. Gemini 2.5 Pro is next.
Mm-hmm. Yeah, Claude heard you complaining about its nepotism and it ranked all the other ones
Oh,
higher.
wow, look at this. This is amazing, right? So in the big prompt, we describe the FAFO framework, and so it can actually interject, the FAFO framework here. So I actually like that. Yeah. So and GPT 4.1 is next. So just to pause for a moment, I actually published a repo of the Google Docs add-on that I wrote in. My first cut was in 3 hours, and I worked on it for days and days afterwards. I just want to show that because it shows the prompts that's pulling. So this is the TypeScript Google Docs add-on. And so part of the prompt that the LLMs are getting is, here's our book, here's part 1, key terms, the FAFO framework, etc. And so obviously in the drafts, it's incorporating some of these concepts from other parts of the book. So I think that's really great. And that was especially as the book grew, it became a richer source for the LM to draw upon. Anything else on that before I stop sharing the screen?
No, I think you can stop the share. I think they get the idea. So we
Yeah.
would go through all this feedback, and it was a lot of it, right? Because I mean, 50 models times 8 paragraphs, you're reading dozens and dozens and dozens of pages, trying to find, what I mean? What we're looking for is sometimes it's a really clever turn of phrase. Sometimes it's a good metaphor, right? A good analogy to bring something home. Sometimes it's they did a really good job with a narrative structure, and sometimes like it's not enough, and we have to we call it Frankensteining it, but you just take pieces from here and there.
Yeah.
Once we're done with that what happens next, Gene? After we Frankenstein it in, we put it into the working doc.
Yep.
And that's when we start the next phase, which is we actually sort of write the section at that point. Yeah.
Yeah, and kind of I'm resurrecting memories. Often when I during this phase, we would often do together, because remember, this is like what we learned is it's easy to branch, it's more important and harder to merge.
That's right.
And
That's
so
right.
in general, in the last 45 days, we did everything together. And
Yeah,
here's what I
everything.
would hear during the writing session: is like sighing, cursing. I hate this. I hate this. Oh, look, it's such a stupid bad writer. And we would just keep iterating on it until we had something that we really loved. And that way when we say we own every word, this is the part of the process that it really makes that true, because ultimately, like, we own every word, right? And if we had just let the LM write stuff and didn't own every word, that's not what authors do.
Yeah, well, I mean, also jokes. I mean, come on, the LM's jokes are generally terrible. We would ask it, come on, make a joke, make a joke. And I think maybe once Claude made a joke that made me laugh. And so, but the book has a lot of jokes in it. We made sure to keep the book kind of light. And so that was kind of an important part, right, of going through each section was, well, there was other thing, not just jokes, personal anecdotes.
Yeah.
Right. I mean, how does this affect us? How did we see this? Right. There's a huge set of personal things that you need to bring into the writing that the
Yeah.
LLM just can't do for you, even if it's read your books before. Right.
Yeah, actually, by the way, one of the things that's always a little bit jarring is when the LLM makes up your own stories. I mean, in other words,
Oh yeah.
it's a little. I was like, where the hell did that come from?
It'll hallucinate a life experience for you. Yeah, back when Gene was working in the military, and it was it's like what?
Yeah,
Yeah. So, but I mean, but still, nevertheless, I mean, even though we wound up having to rewrite everything, it just provides you with such a solid starting point. It's
yeah,
it's the blank page problem that
yeah,
writers face, right?
yeah. And in fact, maybe that's to paint the obvious value. When I prior to this, the way I visualized what writing looked like was me in front of a laptop at a Starbucks, one of two Starbucks that I've written most of the words that have gone into all of my books in, and I start at 8:30 a.m. and my goal is to get 800 words done in a day, and often starting from a blank page. And like, that's horrible, right? And so someone said, yeah, it's like you get to start on the 40-yard line or maybe 80-yard line, right? This work, just takes you so much further, and the goal is to perfect it. And
Yeah, it's not unlike the observation in vibe coding that everybody complains, well, the LLM only got it 80% right or 80% finished. It's like, whoa, you're saying the LLM has made you 5 times faster because you only had to do 20% as much?
yeah,
That's an astounding speed up. That's actually true here too, getting you 80% of the way there so that you only have to focus on like the last 20% of like landing the point just the way you want it and structuring it
yeah,
just right. That makes it so much easier. And that's how we were able to basically rewrite the whole book.
yeah,
Really, I mean, we basically rewrote the whole book in the last 6 weeks. And
yeah.
it was because, I mean, right, things were changing exponentially. We had learned a ton. We had come up with this process by which we could now crank out really good high quality stuff without the merge problem. And
Yeah.
so we just went for it, right? I mean, there are bits of it that predate that, but we really, really cranked out a lot of that book in a short time.
Yeah, two things. One, I think I want to give the Ellens a little more credit. It's like, might not be great at jokes, but like a lot of the kitchen metaphors, I mean, I think they were definitely inspired by some of the drafts that came through the AIs. I mean, it was just some of them were just really, in my mind, flat out funny. The second thing is one of the things we talk about in the book is like you have to focus on automating your own workflow. And I think one of the things that you noticed, I think that you noticed me doing is anytime I was doing copying pasting, I try to automate it away because it was and the NKT formula, NK over T formula explains why, is that anytime we could shave down the cycle time of an experiment and we could increase K, like I think we benefited from that. And I think the reason why is because sigma is so high right now. So sigma represents kind of the risk, reward, uncertainty, and payoff. And what we found is that the ability for AIs to help us in the writing process was so much larger than we thought. And the value of like shaving down the iteration times that I think it paid off so handsomely. And I think the same is going to apply in vibe coding, where anytime you can reduce the amount of copy and pasting you're doing is going to pay off just because, again, they're isomorphic. Sigma is so high right now. The amount of reward you get for the investment of time you put in, the payoff is so fast. And so I think it's another sort of property of this isomorphic chop chow problem. Your
Yeah.
thoughts?
Yeah. And just, I mean, like, ultimately, I mean, like, we didn't do anything with this tool or this process that we couldn't have done ourselves, just sitting down and writing it by hand. There was nothing the LLM provided us other than speeding us up tremendously on the ability to explore instead of us having to, because look, brains first you have to brainstorm and then you have to, right, you expand and you contract. That's how you do ideation, right? And the expansion just goes at which point, you can contract by just picking and choosing, or you can like make it filter them by some other filter or whatever. So you're going through that ideation cycle of trying ideas much, 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 much faster, all because it's formulated with the NK over T
Yeah.
formula. But really, I mean, intuitively, it's just you're able to try a lot more. It's the optionality, the O in FAFO, right?
Absolutely. Oh, so good. Well, hey, Steve, I'm so glad you encouraged us to actually go down this path. I thought that was actually super interesting. It's actually
Yeah,
something I've wanted to do for a long
I
time.
hope people found this useful. I mean, we're not talking about vibe coding per se in here, but we found so much in vibe writing that was like relevant. And I thought the REPL thing was really fun too.
Sounds good. Oh, maybe that's we'll get that on a blog post. Oh, Steve, this has been so fun. So part one, why vibe coding matters. Part two is the theory and first steps. And this is actually something I'm so glad we got to do is start as a chapter to an appendix to it didn't appear at all. So here it is. Part three, the practices to integrate into your inner, middle, and outer development loop. And part four is scaling it to the rest of your organization. So I'm so glad we did this. The Vibe Coding book is available for pre-order on Amazon. And Steve, I'm looking forward to the next episode.
I will see you in the next episode, Gene.
Awesome.